Alright guys, section 9.6, wind and water current problems. You know, any of you who have ridden a bike or you've run or you walk, which means all of you, knows that when you're going with the wind, you can go a lot faster than you can when you're going against the wind. And so there's really two things at work. I mean, there's you pedaling or swimming or running or walking. There's that rate. And then there's the rate of the wind, and either it gets added to your rate or it gets taken away from your rate. Now, I hope that you've heard me say rate several times, because the key, obviously, in these problems, this whole section is going to be that distance equals rate times time. You guys know that 150 zillion times we've done it, okay? But let's see how it fits with these problems. I think you're going to find them pretty easy once you see how you set them up, okay? Now, let's look at example number 1 here. It says that a jet can travel the 6,800 kilometers distance between New York and Paris in 6 hours and 48 minutes with the wind. The return trip against the same wind takes 8 hours. Find the rate of the jet in still air and the rate of the wind. Okay, so see, we're looking for the rate of the jet and the rate of the wind when it's helping it and when it's working against it. Okay, so let's do this. Here we go, with wind and against wind. Remember, these distance problems, they always give us two things. Up the hill, down the hill, right? Two things going in opposite direction, whatever. Always two things. Rate, time, and then distance. So with the wind, we know that the rate is R plus W. Right? We've got the rate of the jet plus the rate of the wind, because the wind is helping us. The time is 6 hours and 48 minutes. I'm going to change that to a decimal, and that's 6.8. You'll remember it's 6 and 48 sixtieths, which is sixth and, let's see, 12 goes into both of those, 4/5, so that's 6.8. Okay? And then the distance with the wind is going to be 6.8 times R plus W. Okay, now let's go over here and let's look against the wind. Rate, time, distance. The systems are really going to help us here. R minus W, and then the time was 8 hours, so the distance is 8 times R minus W. Okay? Now let's write two equations here. I know that with the wind, that the distance, 6.8 times R plus W, is equal to 6,800 kilometers. That's how far we traveled. So this distance has to equal that. All right? Same thing on the other side. 8 times R minus W is equal to 6,800. Okay? All right, let's see. Go ahead and distribute here. 6.8 R plus 6.8 W is equal to 6,800. Find, ooh, look, 6.8, 6.8, 6,800. I'm going to divide everything by 6.8. Can I do that? Sure. As long as I do it to everything. Divided by 6.8, divided by 6.8, divided by 6.8. And I get that R plus W is equal to 1,000. Okay. Let's see what we get on this other side. I'm going to extend the page a bit. 8R minus 8W is equal to 6,800. I'm going to divide everything by 8. I can do that. Now R minus W is equal to 8 goes into 6,008, goes into 64 8 times with 4 left over. So then it goes into 45 times, so 850. Now look, oh, perfect. I'm just going to put one equation under the other, 850. You know what, I'm going to add and get rid of the W's, right? Is that okay? And I'm going to get R plus R is 2R. These two just cancel because they're opposite signs. And this is 1850. When I divide by 2, I'm going to get R is equal to 925. Now that's the rate of the jet. Now, remember, R plus W is equal to 1,000. I'm going to have to finish this on one other video. Can you believe that? But I'm going to be right there. So, see you on the next video.